University College Dublin Humanities Institute. For more information, go to ucd.ie/humanities. In this episode, a recording from the Irish Memory Studies Network Distinguished Lecture Series on the theme of methodologies of memory. This series is generously funded by the UCD College of Arts and Celtic Studies and the Irish Research Council's New Foundation Scheme. The fourth lecture in this series was given by Dr. Fred Cummins from the UCD School of Computer Science and Informatics. His lecture, The Folly of the Engram, Considering Individual and Collective Memory, was recorded for podcasting by Real Smart Media.
Delighted and somewhat perplexed to be invited to give a talk in the memory series. As I made very clear to Emily at the start, I don't know anything about memory. It's one of those words that have stopped working for me. Like language, I have to use some neologism like languaging. But maybe if I talk a little bit about it, you might get a sense of why that word falls apart somewhat. And as a cognitive scientist, I sort of have a feet in very many camps. And the topic of memory, of course, has a feet in very many camps. And I thought it would be interesting to explore two rather distinct senses of the notion of memory that seem to be crystallized here in this lecture series. So 2 weeks ago we had Keith Murphy here from UCD talking about the neurobiological basis of memory, which seemed oddly contrasting with the concerns of the rest of the series that have had to do with such issues as memorializing, retelling stories, interpreting histories and such like. And it struck me as there's a big sharp disconnect there between the language of toilet cleaner blue brains with shiny neurons and memorials and this business of sense making. And I wanted to know, are these guys having a discussion, or are they at odds with each other? Is there a complete failure to understand? How can you make the links? I found it very difficult, having attended the talk 2 weeks ago, to make the links from talks of synaptic plasticity in rats to remembering 1916. I'm sure I can tell other people here are equally sort of perplexed by it. And so at root here is a basic sort of question about whether memories are something that we have or whether memories are something that we do. That's a very simplistic way of putting it, but the two verbs, to have and to do, I think serve to cleanly separate the two kinds of story that are emerging here. And I want, by way of introduction, I'm going to recap a little bit of the talk from 2 weeks ago. I'm sorry, it won't be long. I know it's familiar, and I know you have difficulty. We got to look at the nervous system account first before we can critique it. For a critique is what I have in mind. The basic idea is that when neuroscientists talk about memory, they talk of something that we have. They talk about changes to the connections between individual nerve cells in the central nervous system. The gaps between the nerve cells or neurons are called synapses, and they are changed on an ongoing basis as a result of our experience. There's an awful lot of neuroscience in this area. It's been a concern ever since there's been such a thing as neuroscience. And I'd love, my favorite places to find out what way things work are Twitter and Google image search. So if you do Google image search for memory, it seems like a lot of people are in the brain and synaptic change camp. This is literally the first page of results if you search for images about memory. Notice how few memorials there are here. There are no crosses, insignias, no rituals, rites. There's a whole load of toilet cleaner blue brains. We have a green variant there. And a little bit of colour. The blue, we'll come back to the blue. The idea that we are changed by experience and that this is somehow related to the notion of memory is a very old one. If we go back to Plato said, imagine that our minds contain a block of wax. Whenever we wish to remember something, we hold this wax under the perception of ideas and imprint on them as we might stamp the impression of a sealing ring. Now, one thing to beware of course, if we're doing the traditional academic arrogant thing in bringing in Aristotle and Plato when we're not, I am firmly not a classic scholar, is the words here, mind, ideas, perceptions, these are all completely untrustworthy across such a divide. They're not even stable in latter day 2015. If you walk around UCD, you would find completely different ideas of what an idea or a perception or a mind are. But the idea of an imprint, that there is an imprint which stands behind memory, is a very powerful one. And it's the idea of the engram, which is an old term. It comes from a guy called Richard Simon, who he was a neuroscientist before the First World War. He was very unhappy at the outcome of the war, and he committed suicide in 1918, wrapped up in a German flag, and has otherwise vanished into history. But the term that he gave us, the term of the engram, is the idea of a trace, of a memory trace that could be found in brains. Now, he was working, as I said, before the First World War, and this was an area of intense interest in neuroscience. The central nervous system had only recently been resolved into individual cells. It was the last part of the body at which it was found that, yes, this tissue too is composed of individual cells. It's more obvious in other kinds of tissue. It's very much less obvious in nervous tissue, and it required the development of specific staining techniques to bring out these kinds of wonderful structures. The drawing on the left is by Ramon y Cajal, who was a neuroscientist who, together with Camilo Golgi, was awarded the 1906 Nobel Prize in Physiology and Medicine. First time it was ever awarded jointly. Golgi, his co-awardee, had developed a staining technique using silver nitrate that washed away a lot of the goo, for brains are very gooey, fatty things, and washed away a lot of the goo and left these beautiful, absolutely beautiful structures, clearly outlined in black and white. And this is a drawing he did. He was slightly better than Golgi at both the staining and the drawing. He captured fine details that Golgi didn't. But you can see how well and accurate he's got it. This is a particular kind of cell, a Purkinje cell, and on the right you can see an scanning electron microscope picture of a Purkinje cell in toilet cleaner green. And you can see how much of the detail he's got right. He's a phenomenal attention to detail. And although these two guys who were awarded the prize differed in what they considered the basic character of the nervous system to be, Cajal's view, which emphasized the role of these individual cells called neurons, held sway and has informed neuroscience for more than 100 years now in something called the neuron doctrine. The neuron doctrine is the idea that these particular cells, the nerve cells or neurons, very peculiar cells, that they are the atoms of the nervous system. They're the thing you need to understand, and the activity in those, and it's within a cell it's mainly electrical activity, and between cells it's chemical activity. We need to understand that if we're ever going to understand the nervous system. This is a nerve cell, a neuron, and you can see it has a body and it has a bunch of tree-like inputs, as it were, dendrites. They receive chemical signals from other cells which accumulate, and if collectively they pass some threshold, then an electrical signal is generated which passes down the long projection called an axon and is passed on again chemically to other cells. And some of these axons can be literally this long within the body, and they're very, very fine. Now, that neuron doctrine emerged around 1906, and it is crumbling at the moment. We have lots of reasons to doubt the neuron doctrine, though they are rarely held out in public. But it has informed all of neuroscience for over 100 years. The search was then on for memory, specifically an initial simple idea, which is that one could locate an individual change to these synapses that might be linked to a specific event and that therefore might form the basis of a memory of that event. That didn't really pan out. One of the most enthusiastic and industrious searchers for this trace called the engram was Carl Lashley, who did lots and lots of experiments on rats, among other things. Rats running mazes seems to be somehow have become a model for memory, which, as we approach 1916 and the intricacies of memorials and rituals and parades, we might wonder what the relevance of rats running mazes is in this instance. Certainly no engram was ever found, and Lashley reasoned that it must be widely distributed so that one couldn't find a strictly local trace. Now, I've already pointed here to a conflict in vocabulary. The way that the term memory is understood in different communities seems to speak of a vast divide. As I said, remembering 1916 and rats running mazes seem completely incommensurable. Now, in discussing memory, psychologists have grappled with the topic of how we live with our past, how the past informs our present, and perhaps how we project the past into the future. And in doing so, memory, for them, too, stopped working and became very many different things. So psychologists have distinguished between things like short-term and long-term memory, episodic and procedural memory, autobiographical memory. And there's all these divisions which are treated as if they were clear. They are anything but clear. They simply illustrate the complexity of the topic and the number of different ways that word is wielded and conventionally used. And I have found in teaching cognitive science to undergraduates that I used to teach something on knowledge representation and I used to teach on memory, and I slowly realized that my slides from the two sets of talks were almost the same slides, for we can speak of procedural knowledge and propositional knowledge, which would be declarative memory, and procedural memory is a common distinction. We can speak of the same distinction in knowledge of things that we know or skills and capacities that we exhibit in specific situations. So the term memory in the psychological domain has become very, very complex and is not clearly distinguishable from knowledge, to know. And of course, when we inquire into the nature of knowledge, we're approaching something we care a lot about, but we need to treat with a great deal of caution. And I'm going to interject the first of a long series of complaints about the psychological goings-on, which is the history in the entire history of psychology and its neglect of the role of context, the fact that we do things in specific context. This has been a tragic sort of continuous thread throughout the history of psychology, which is you take someone out of a life world in which they function and get by, and you stick them into white rooms and get them to regurgitate meaningless lists of words and numbers as if this were the basis for memory. We'll come back to this role of context in a little bit. There's a cartoon just to illustrate it. fMRI study found that subjects performing simple memory tasks showed activity in the parts of the brain associated with loud noises, claustrophobia, and the removal of jewellery, which might perhaps have something to do with the context in which the studies are run. I'm not sure. Yet one still speaks with some confidence of memory in the neuroscientific area. So we met, for example, the absolutely classic case of HM 2 weeks ago, who had damage to a specific part of his brain, the hippocampus, which was removed in 1953 to treat a kind of epilepsy. It wasn't mentioned that this was inappropriate, it turns out. It was actually a medical error. He lived a long time. He only died, I think, in 2003. And he lived with a severe form of amnesia, by which we mean his surgery was in 1953. He could tell stories about the time from his birth up until about 1950. He was uncertain about facts between 50 and 53, and he, we say, formed no long-term memories, and I wish to query what those words mean, in the time between 53 and the day he died. So he constantly had to be reintroduced to the doctor who was treating him, for example. A kind of a floating existence in a bubble. It's weird. His case has formed the basis, was one of the linchpins of the case that memory is stored in brains. And we've also uncovered very many mechanisms by which these synapses, these gaps between nerves, are modulated by experience. The brain is an incredibly plastic organ, and your brain after a cup of tea is different than your brain before the cup of tea. You go into the conversation, one person, you come out, I won't say a completely different person, but you come out with some modified synapses. We know an awful lot about the very complex mechanisms subserving this kind of thing. The term long-term potentiation was bandied around. This was first guessed at in 1949 by a chap called Donald Hebb, who made a brilliant guess as to how the nervous system might be modulated by experience, and that was experimentally confirmed in 1973 by Bliss and Nomo. And since then we've had many other forms of neuroplasticity, this capacity of the brain to be modulated by experience. Another very famous one which wasn't mentioned and is, from an empirical point of view, decidedly dodgy, is this study of the hippocampi, again the hippocampus, of taxi drivers in London. Taxi drivers engage with the world spatially in a way that most of us don't, and it was found that those who were longer in the job had by some measure, larger or denser neural connections in their hippocampus than others. So this is structural change to the brain as a function of the experience of the taxi drivers driving a cab around London. I hope those of you with any empirical chops are looking at that graph and going, I hope they didn't base the result on that correlation. Right? They did. And this is another very famous example of how experience modulates the brain and why we come to believe that memories reside in brains. But there's a very important piece of the development of the neuron doctrine that's usually de-emphasized, as if for 100-odd years we had a single view of the brain. There was a massive change in the way we think about the brain between about 1940 and 1960, with the origin of the terms computer and information science, information theory, control theory, and so on. This all happened in a couple of decades around the middle of the 20th century. Claude Shannon, working at Bell Labs, developed a precise mathematical theory called information theory, which allowed one to quantify the business of the exchange of messages between a sender and a receiver. And that fitted very well in an intellectual landscape that was coming to terms with the notion of a computing engine. John von Neumann, a very enthusiastic military chap, had come up with an architecture which still forms the basis of our computers today. And people were thinking about computers. Imagine if you had a machine that could do all this math, all these calculations. What would that do? And there were some very infamous at this stage results in the theories of computing. Alan Turing is well known to everyone from the recent film. He had come up with showing some very general results in mathematics, showing that the class of things that could be computed could be identified. You could talk about, you could make meaningful distinctions in that area. The notion of cybernetics and control theory was of grave interest to the military. It was thought that the brain might control the body in the way that a controller might control a missile. Choose a random example. And at the heart of this is the guy pictured there on the left who really needs more attention than he gets. This is Warren McCullough, a chap who was an engineer, a psychologist, a psychiatrist, a neuroscientist, and a poet, among other things. A very deeply religious chap from an Episcopalian background. McCullough was very interested in computing and the relationship which he postulated between computers and brains. It's largely to this guy that we have the view that we might think of the brain as a computer. And he did so by making enormous simplifications. It's worth looking at those, though we won't do so today, in order to see how you can make that equivalence. For the brain is a lump of fatty meat, and computers at this stage were more of a mathematical idea. Now they live on our desktops. It's still not clear that it haven't turned out to look like lumps of fatty meat yet. The simplifications that Warren McCullough needed to make are very important, and there's no obvious equivalence between the two. But he insisted that one could profitably view the brain as a computer, and if so, computation would provide a way to understand how we feel. He was interested not in intellectual tasks. He was interested in he was more of a phenomenologist. He liked the idea. He wanted to understand the subjectivity, the feeling, and he wanted to ground his religious belief in a transcendent God in his theory of computing. Now, this is normally not emphasized. One forgets all this, but this is very important that this equivalence we take today between brains and computers has a deeply religious origin. This perfect storm of intellectual progress then gave rise to a whole bunch of disciplines that are still with us today, and modern linguistics was a very important part of it. It birthed what we now call as cognitive psychology and the disciplines of artificial intelligence. And the language that arose here changed things. The language of information processing, in which data or information is stored in memory. This has a very precise meaning when we're dealing with computers. As we all know, we have things like hard disks and flash drives, and we use the word memory for those, where we store data, we inscribe data. And so now synaptic change suddenly, and almost imperceptibly, became to be viewed as the inscription of experience in the brain. And this is a very significant change. This was not something that was available even as a language to use before about 1950. And it is this notion that experience could be inscribed in the brain that I want to make manifest. I want to ask you to take that notion out and look at it in the daylight. How odd is this. If I were to ask you to attend to your own present unfolding locus of experience between there and there, what exactly of that would be inscribed in the brain? Does it not require the inscription of the entire world with all its possibilities for the things you can attend to, for example? I don't know. I don't know what it means to inscribe experience in the brain. I suspect it's deeply incoherent. But it's not a new idea. This notion that the brain is the seat of experience and the locus of executive control is something we need to query, and to do so with a suitably broad historical perspective. This did not arise in 1950. This has been going on for hundreds of years and is specific to our part of the world. It's specific to a particular cultural historical progress which we can trace back at least as far as the Renaissance, the Reformation and the Enlightenment, as we see an increasing focus on the individual, the autonomy of the individual, and the agency of the individual, and indeed the moral responsibility of the individual. These are, of course, deeply theological notions which have become developed, but they've found application way beyond the domain of religion, and we have founded our societies on them. Our notion of legal responsibility is built on a particular notion of agency, for example. The notion that experience is individual and private isn't naturally available to everybody. That's something you have to be schooled in, and we are schooled in it in this part of the world. So that now, as we came to see the brain as the possible locus of inscription of experience, this is a natural progression of this. And it's with that I want to come back to those blue brains. Let's just have a look at the images that are so inflaming the imagination. Here's a selection of the kinds of images that one sees these days when one looks into neuroscience articles, pop articles, blog posts, anything to do with the brain. Look how shiny they are. Look how blue, toilet cleaner blue they are. Look at the weird things coming out of them as if they were atoms or radiation. Some of them don't even look like brains. They're just reduced to glow. There's no shortage of these things. You've all seen them. There's one particular graphic artist in Seattle who seems to be responsible for an awful lot of them. When you look at the one in the top right-hand corner, look how the brain has gone completely from this, but the projections into the cosmos or is it to the transcendent God, they're still there. And you ask yourself, these seem familiar, and they should seem familiar, for this is the way the Holy Spirit has visited us. This is a deeply religious vision still. This notion of the brain as some kind of computer into which you can inscribe the entire universe didn't come from nowhere, but it is not a neuroscience, a fact established by neuroscience. This is the background assumption in which conventional cognitive neuroscience is developed. I have to thank Alexander Grieser, who's a professor of religious studies in Trinity, interested in the aesthetics of religion, for bringing these beautiful blue brains to my attention, and she also just made this gorgeous juxtaposition. And with this, you can see on the left, you can see a rather extreme example of this kind of toilet cleaner blue aesthetic in which all the personality is wiped away. We've got essentially the person who's reduced to a center of subjectivity which projects outward and includes all of science, apparently. And the famous painting on the right, the Caspar David Friedrich painting, in which we are no longer looking at a world or at a person, we are looking with the person, we are almost looking through the eyes of the person. This is a painting which emphasizes the perspectival, subjective view of the subject. So we have this fetishization of the subject, and with the German romantic view, of course, we have a new kind of a religion. You're familiar with the term. I'm not religious, I'm just spiritual. This has its origin, of course, in German Romanticism. There's something going on here that has nothing to do with synaptic change, in other words. And I want to pull back and look at what a brain actually looks like. They are messy lumps of meat with fat, gooey. And neuroscience, when it deals with the lumps of meat, uses terms like cell, action potential, ganglion, thalamus, receptive field, a technical vocabulary with which you deal with a physical object that does stuff. It's quite good. The problem arises when terms that relate to the person, which is, of course, a term that needs negotiation. These terms come from psychology. When we speak of memory, recognition, emotion, intention, perception, belief, and so on, we are dealing with stories we tell about ourselves which do not necessarily map onto fatty lumps of meat, do not easily admit of being stuffed into that particular mold. And the relationship between the wet neuroscience and the terms of psychology surely needs to at least be discussed and not to be taken as a fact, which this relation does not belong to the neuroscientist any more than it belongs to the memory researchers in the humanities. It belongs to all of us and none of us. We need to negotiate it. In the meantime, there's been a lot of change in our view of the nervous system. Neuroscience proceeds at a vast pace. Those synapses that we thought were modulated by experience, they turn out to be an awful lot more complicated than we thought. They are not simple. They can't be captured in the simplistic way that these models, for example, from Warren McCullough came, which attributed a single number to the strength of the connection between two things. We now know that some of those cells that got washed away in that staining process, the astrocytes, the glia cells, the stuff that we thought was just insulation and scaffolding for the real business of neurons, that's doing some computing, if you like, as well. That's absolutely involved in all the dynamic activity of the brain, regulating so that a single synapse now becomes itself a little feedback controlled system of enormous complexity. So we can no longer view them in the same way as a possible locus of inscription. The nervous system itself has become, we've slowly become aware of the fact that the nervous system is always active. And this is some beautiful imaging. I mean, imaging has got really good. This is almost all the neurons in an active baby zebrafish, and you're seeing them changing in real time there. You're also in the top left-hand side seeing some black and white grills that are going to move, and there is a massive change in the activity of these neurons in this zebrafish larva. Isn't that beautiful? But it's an endogenously active system. It's always doing something. It's pulsing. It's making sense of the world. It's doing things. It is not something on which you simply inscribe something. It's not the passive recipient. It doesn't respond to stimuli. It is a system that encounters a world and interacts with that world. And so within the cognitive sciences, which is where I come from, the view of the brain as an information processor and the view of cognition as computation is no longer the only game in town. You would not know that to talk to an awful lot of people in the business. It massively dominates the language of contemporary cognitive neuroscience. That's that mapping from the wet stuff to the terms of psychology. This is a theatre of fanciful projection where everyone on both sides needs to be called out, called to account. You cannot simply lean on this view of information processing without challenge these days. The role of the body, the relationship between the brain and the body has become very a focus of great attention. Many people will be aware. The fact that many of the things that we thought of as internal and probably in our brain are actually in our practices and processes in the stuff of the world, this notion of extended mind, and that much of the things, the apparent feats that we thought of as belonging to the individual are achieved collectively. These notions of embodiment, extended mind, and distributed cognition have radically changed the way that we view the role of the individual brain, but there's an awful lot more coming down the line. In neuroscience, the neuron doctrine, as I said, is crumbling for very many reasons. We found it was a great first guess, but it's not going to stand up. So if we don't push the soul back into the brain, if you like, if we don't put all of human experience into the brain, we have to ask, well, what is it to be a sentient, experiencing being? There are important movements now, and I'm just gesturing to them here, and that we ground this in the notion of life rather than in the notion of a nervous system. The mind and life and inaction collectively refer to deeply different stories that we are now beginning to tell, and that likewise have claims on neuroscience, and so we need to negotiate this. These fundamentally different approaches to mind and brain will be unfamiliar to many of you. I'm not going to go into them. I'm hoping, though, to sow the seeds of doubt about the received approaches that we got. Where these different approaches really starkly diverge comes down to how we interpret patterns of activity in brains. And the language that is used in the one camp, in the information processing camp, is a language of representation. This, again, is a venerable language. There are many ways to use the terms representation, and there's an awful lot of hot air expended in discussing the merits and demerits of this notion, which unpacks to very many things. But there are basic questions here about how a physical pattern, a physical pattern. That's what synaptic change would be. How it can be about something in the world. If we were to call that change a memory, it would have to be about your last summer holiday, for example, or that car crash that you saw on the way in, or something. And here, I have to say, I put it there. I'm opinionated, I'm in a minority, okay? So if you buy my snake oil... However, I want to look at one of the most best worked out and probably familiar notions of representation in the brain, which is usually, by those for whom questioning this notion doesn't come easy, taken as absolute proof that the brain is full of patterns of activity that are about things in the world. And this is the development of things like these homunculi. This is the somatosensory homunculus. And there's a part of the brain that lies, it's a strip right around here on both sides of the brain. And if you touch someone on the skin, you can identify associated nervous system activity in a particular place on this strip. It's because there's direct connections from the nerves and the skin, like with just one or two synapses. And this is where the nearest bit of activity in the brain is. And so we can form a mapping from the skin to this part of the brain, and it's shown there, and you can see some parts of the body, I'm sure most of you are familiar with this, some parts are more sensitive than others. You don't feel very well with your elbows and your knees, thank God, but you do feel very well with your lips and your hands. So we get these grotesque distortions, and you can see there is a mapping, a principled lawful mapping from the distribution of receptors in the skin to the sensitivities of these individual nerve cells. Some people look at this and they say, that's a representation. We can clearly see, we have established scientifically that nervous system activity here is about something that's distal. But actually we can follow those threads, those individual nerve connections, and it takes us right back to Plato when we do so. For Plato spoke of an imprint, didn't he? He spoke of imprinting as if on some wax. Now here are two imprints, one of lips on glass, one of a hand in clay. These are unproblematically about past things. They're about past events. They no longer are the events. They are also not memories of the events. They bear traces of the events, and when interpreted, they allow us to construct stories about those events. But the events, alas, are gone. Now we're coming back to something that should be more familiar, I think, to memory researchers in the humanities, which is a notion, I got this from DJ Spooky, the notion of material memory. Perhaps some of you are familiar with the idea. This is not, as the neuroscientists would have it, the inscription of experience, but it's the integration of physical objects, physical traces, physical things, into processes of sense-making. This is probably a more familiar ground now for people for whom the word memory speaks of things like, 1916 is coming up. What I want to see is how can we take this kind of language, can we use that to understand also what goes on in brains? For we are in brains dealing with physical changes as a result of experience. And there was a beautiful example of material memory and how these traces don't interpret themselves. That was spotted by a colleague of mine on the far side of the campus, beside some bins. I can't resist this. I'm going to read that one out to you. This foundation stone was laid by President Dr. Hugh Brady, 16th of November 2010. And it says the same thing in Irish. And it's been thrown out in the bin heap already. What was it of? I'm sorry. This is the least successful foundation stone in history. Obviously, this is not a memory. It's a trace which is designed to help us to commemorate something, and we've lost the essential thread. I was in Bristol the week before last, and I came across this. There's a plaque there. Unfortunately, my camera was really crap. It was just a camera here. You can't see what it's a commemoration of. Somebody important was around here in this building, but if you pull... I was just waiting for a bus. I thought I'd share this with you. If you pull back, the building looks a little bit odd. Those windows don't look quite real, and if you walk around the corner, you can see this building is a fake building. It's a facade. It's this thick, but they preserved the front of it because the commemorative plaque was in there, right? And they built freely and in grotesque modern style. So I thought that was rather funny, and I thought that spoke very eloquently again of a material trace with which sense-making is done. That facade is necessary in order to provide the necessary context to follow those threads back to whatever it was that happened. So memorials don't make sense of themselves. They are physical traces that we integrate into our practices of sense-making. Now, there's a further contributor to this fanciful notion that there is such a thing as an inscription of experience. And it comes from the very modern technologies of recording, sound recording and video recording. So both of these, of course, again, arose around the beginning of the 20th century. But we have to remember they, too, do not capture experience. They are physical traces that allow us to reenact certain kinds of experience, and absent someone to interpret them, they are about precisely nothing. Hard to remember. Beyond material memory, and this is where there's a slight connection now with my own work, we have to acknowledge we have other means of stabilizing our stories. It's not just in things that we etch into stone. It's also in the rituals and rites that we create. What is it? Do this in memory of me, I think they say at Mass, isn't it? So my own topic of study is collective speech, when we speak together, and we do so by and large at situations of great emotional intensity and situations that are accorded huge degree of significance. So we've integrated these practices of speaking together as a means of ensuring that people do things in the same way again and again, and that experiences are reenacted. This is a notion of sense-making that goes beyond the individual. It's collective sense-making, and there's no principled distinction once we start talking about memory like this. There's no principled distinction between the sense-making activities of an individual and the sense-making activities of a group. So on this view, memory, it seems, is something that we do. Now, neuroscientists may not be happy with this, but I see no way around it. We retell stories, we reenact experiences, and in doing so we lean on these physical traces, we lean on these activities, we lean on the practices of prayer, the rituals, the rites. We lean on these things to stabilize things so that again and again and again we can have related bunches of experience and we can enact certain ways of being. This approach to memory does not seem to me to be as infused with souls and problematic theological constructs. There's no need to appeal to shiny blue brains reaching out into the cosmos in order to do this. And I'm going to wrap up. Cognitive science has a history of attracting people with Nobel Prizes. And of course, if you have a Nobel Prize, people believe any old crap that comes out of your mouth. Francis Crick of Crick and Watson, who decoded DNA, then turned to the brain, and he came up with what he called his astonishing hypothesis. The hypothesis in question is that you, your joys and your sorrows, your memories and your ambitions, your sense of personal identity and free will are in fact no more than the behaviour of a vast assembly of nerve cells and their associated molecules. Why is this facile nonsense not challenged more often, more directly, and with a little more chutzpah? Okay, just because someone has a Nobel Prize does not mean that they have the high road to the truth. If we were to follow The Onion, another great source of scientific truth, who warns that the past is expanding at an alarming rate, historians can make sense of that, of course, because the amount of activity around the past generates an awful lot more text, and in some sense the past is expanding. And if you were to suggest, if we were discussing history instead of memory, and you were to suggest that history simply exists without argument, without negotiation, construction, revision, creation, narration and interpretation, you would be laughed out of here, I presume. And there's not a historian in the world who believes that history is just there to be read. History is an activity. And that does not turn history into creative writing for all those who are afraid of the spectre of relativism. It does not suggest that the processes of negotiation, discussion and interpretation are either redundant or unnecessary. And here's the crucial thing. It does not situate history on either side of some specific subject-object divide. That seems to underlie an awful lot of the problems here. And so I have a final point, I suppose, which is that if we regard this notion of the engram as something that we can expect to find without further qualification in brains, if we go looking for memory traces in brains, we are abdicating responsibility for telling our own stories. We don't get off the hook that lightly. We are responsible for our own memories as we are responsible for our own histories. And I'll stop right there.